What chemical transformations happen in everyday cooking? Imagine biting into a perfectly toasted piece of bread or savoring a tender piece of grilled chicken. What makes these foods look, taste, and smell the way they do? The secret lies in the chemical changes happening during cooking. When you cook meat or eggs, the proteins in them change their shape in a process called denaturation. This makes the food firmer and easier to digest. For example, eggs turn from runny to firm when boiled because their proteins unfold and bond differently. The Maillard reaction is what gives browned foods their rich aroma and flavor. It occurs when amino acids from proteins react with sugars at high temperatures. That is why grilled steak, toasted bread, and roasted coffee all develop that deep, savory smell. This reaction is temperature sensitive and starts around 165 degrees Fahrenheit or 74 degrees Celsius. Caramelization happens when sugars are heated above 165 degrees Fahrenheit or 74 degrees Celsius. The sugars break down and form new compounds that taste sweet and nutty. That is why caramel sauce, roasted vegetables, and browned onions have that appealing golden color and complex flavor. Fermentation is a natural chemical process where tiny microorganisms like yeast and bacteria convert sugars into alcohol, acids, or gases. This process is behind bread rising, yogurt thickening, and the tangy flavor of sauerkraut. Fermentation also boosts the nutritional content of some foods. Acid-base reactions are common in cooking. When you add vinegar or lemon juice, the acidity can tenderize meat by breaking down proteins. Baking soda, which is sodium bicarbonate, reacts with acids in recipes to produce carbon dioxide gas. This gas creates bubbles that make baked goods fluffy and light. Emulsification is what keeps oil and water mixed together. Egg yolks contain natural emulsifiers that help create stable mixtures like mayonnaise and salad dressings. Without emulsification, oil and water would separate quickly. Oxidation occurs when foods like apples or avocados are exposed to oxygen. This causes browning, which is a chemical reaction involving enzymes. While this can make food look less appealing, it is a natural process that can be slowed down with acids like lemon juice. When making bread or pasta, gluten formation is essential. Mixing wheat flour with water activates proteins called glutenin and gliadin. These proteins form a stretchy network that gives dough its elasticity and strength. This is why bread can be kneaded and shaped easily. At very high temperatures, organic materials undergo pyrolysis. This process breaks down food chemically without oxygen, creating charred flavors and crispy textures. Think of the crust on a grilled piece of meat or roasted vegetables. All these chemical reactions are happening every time you cook, transforming simple ingredients into flavorful, appealing dishes. They also influence the nutritional value of your food, making some nutrients easier to absorb while reducing others. Understanding these transformations helps explain why different cooking methods produce such varied results. Whether it is browning, tenderizing, or rising, each change is a chemical process that makes your food more delicious and satisfying.